Small things can make huge impacts. Most of the greatest discoveries of all time were discovered accidentally. But will you believe me if I told you an idea about the great grand universe was noticed from the noise or distortion? Yes, I am talking about that old and annoying noise. It was the time when people were trying to explain the universe through models, as telescopes were not enough to observe the far galaxies. You have to know a few names of scientists, which could be boring, but what they discovered will be the highlight. One of the important universe models was Friedmann's model. He imagined and presented the universe as a balloon. You see, when you blow a balloon, it expands overall. The expansion is not fixed to, say, the center of the balloon. The entire volume is actually expanding as a whole. Similar to that, Friedmann explained the universe was expanding and it doesn't have a central point. On the other hand, we had another scientist well known for inventing telescopes, Hubble, who was at the attempt of cataloguing the planets, discovered a supporting evidence for Friedmann's theory. We will look at what he observed later in this video, but all of these were just at the level of assumption theories until noise came to rescue. Years later, Arno Penzias and Robert Wilson were using a very sensitive microwave detector, working on a different experiment. It was then they realized something odd about the detector. Even before they were off with the experiment, there was a distortion which they found as a distraction. Unlike today, they didn't have noise cancellation technology, so they checked if the machine was faulty and even checked the components of the detector to find the source of the noise. Later, they realized that when the detector's direction was changed, the noise changed slightly. It was then they understood that the noise was coming from the atmosphere. Now, don't get any ideas. It was no aliens sending messages to Earth, but indeed a message from the beginning of the universe. Simultaneously, two other scientists, Dick and Jim Peebles, were actually looking for this noise to get a glimpse at the glow of the early universe. Apparently, they were looking for the light emitted when the Big Bang happened. If you watched one of our videos on aliens, you will know that light, despite its speed, takes time to travel and reach distant locations in the galaxy. These two scientists believed that the earliest light of the vast universe will be reaching Earth only now, after traveling for a few billion years. Even they had a twist in story, as light from the early universe, when it finally arrived here, was not light anymore. Before we could go any further, head on to our channel to find more interesting videos. Do not forget to subscribe to our channel and ring the notification bell so that you won't miss any of our videos. The light from Big Bang, or can also be called the light from the beginning of the universe, appeared as microwaves when they reached us. This means we can only detect them, but cannot actually see them. Speaking of the facts, light, microwave, radio wave are all electromagnetic waves. The visible light wave, which gives us what we see, has its own specific frequency. Microwaves have lower frequency compared to the waves we see as light. Coming back to what made the light waves to become microwaves is the Doppler effect. Wait, let's not just drop off here. It's not as complicated as you think it is. Have you realized a car from a distance tends to have a higher pitch sound as it comes closer to you? Then you can actually realize it will fade off as it passes by, moving away from you. This variation of pitch and frequency in terms of wave is called the Doppler effect. When the waves approach a body, their frequency increases and vice versa. The only thing different now is that we are going to replace sound waves with electromagnetic light waves, and our so-called road will be the space between our planet and the point where the earliest light is coming from. The Doppler effect explains the change of waves produced by a moving object as observed from the stationary object. To us, Earth is the stationary object. Since the Big Bang is basically an expansion, we can call the point from which the light of Big Bang was produced is moving away from us. Due to Doppler effect, the frequency of light waves that reach us from the edge of the expanding universe will have gradually decreasing frequency and increasing wavelength. This increase in wavelength of light is called redshift. Now, due to the very large distance traveled to reach Earth, our light waves are so much redshifted that their frequency was reduced to that of microwaves by the time they were detected by Penzias and Wilson. The same concept led Hubble to support Friedmann's model of the universe. When Hubble used his telescope to look at the planets, he had to capture light from them, which is how basic vision works. Now that he realizes most of the planets he was observing were emitting redshifted light waves, it gave him a strong reason to believe the universe was expanding, as this observation of redshifts indicate the planets are moving away from us and also from each other. How will that be possible in the first place if the universe was not expanding? Although these thoughts were around for some time, it was the discovery of noise detected years later that led to more certain conclusions, convincing the world of science. So, that annoying noise that we try to avoid in our communication devices is not as bad as we thought they were. That's all for now, folks. Don't forget to share this video with your friends. See you with a more interesting video real soon. Till then, stay tuned with Quantum Vimana.